Okay, so let's continue with our discussion of op amps. Okay, so last Tuesday, I discussed with you the model of the op amp and what an ideal op amp's characteristics are. No? And I said that analyzing op amp circuits, you can break it down into 4 steps. So these are the steps that we developed to analyze an op amp circuit, which uses ideal operational amplifiers. First, that you check that there is negative feedback. Okay? If you will recall, negative feedback is very important because this is what prevents the op amp from immediately saturating. This is what regulates the value of the output voltage so that the op amp does not immediately saturate. No? Second, you apply the golden rules for ideal op amps operating in the linear region. And those rules are that the inverting input should be equal to the non-inverting input, or V plus is equal to V minus, and that the currents flowing through either the inverting or the non-inverting input would be equal to 0. And then you use nodal analysis. There's something wrong with the numbering here. No, this should be number 3. You use nodal analysis. And finally, you check for saturation. So those are the steps in analyzing op amp circuits. And we used these steps last Tuesday to analyze some standard op amp circuits. So what were the standard op amp circuits that we took up? Okay, we took up the inverting amplifier, the non-inverting amplifier, okay, we took up the buffer, we took up current to voltage converter, and we also took up the inverting summer. Inverting summer. So what I'm going to do this afternoon is just continue with examples. So what's the next example that I want to take up? I want to take up with you the non-inverting summing amplifier. So we have an inverting summing amplifier. We also have a non-inverting summing amplifier. Okay, so how do we analyze this circuit? Okay, first of all, meron ba tayong negative feedback? And the answer is yes. If you notice, a portion of the output is fed back through a feedback resistor to the inverting input. And that's essential. No? The feedback should always be to the inverting input. So this has negative feedback. So there's a good chance that it will be operating in the linear region. Okay, next, we apply the rules for ideal op amps. No? So what are the rules for the ideal op amp? Okay, so you have V plus, the voltage at this point is equal to the voltage at that point. No? V plus is equal to V minus. And then the other rules for your ideal op amp are the currents here will be equal to 0. No? So this is I minus is equal to 0 and I plus is equal to 0. And then we apply nodal analysis. Okay. So let's do that. Let's apply nodal. So the voltage here is V plus. Okay. The voltage here is V minus. Let's apply nodal analysis at the non-inverting input. So KCL at the non-inverting input. Okay, can I ask Albert to provide me those Kcl equations for my non-invert, or the Kcl equation for my non-inverting input?
Bali po, V.
Go ahead.
V positive po.
Okay, V plus.
V plus minus V1.
Okay.
Over R1.
Okay.
Plus V plus over V2 over R2.
Minus V2, no? Over
minus
R2.
V2 over R2 plus V plus minus V3 over R3 is equals to 0.
Okay, no? So that's KCL at the non-inverting input, no? So this is V plus. Okay, so we can solve for V plus. Okay, V plus multiplied by 1 over R1 plus 1 over R2 plus 1 over R3. This is going to give me V1 over R1 plus V2 over R2 plus V3 over R3. No? And I can rewrite this in terms of conductances. Okay, I'm going to get V plus. This is going to be G1 V1 plus G2 V2 plus G3 V3 all over G1 plus G2 plus G3. So this is not the first time you're seeing this equation. Do you remember what this equation is? Can someone recall? Ano yung tawag natin dito? What type of equation is this? Lala nyo ba? No? This is your weighted average. No? Weighted average. Right? Where G, of course, G is conductance, it's equal to 1 over R. No? So that's your weighted average. So the voltage at your non-inverting input is just the weighted average of your inputs, V1, V2, and V3. Okay, if we apply now KCL at the inverting input, sorry. So KCL at the inverting input, okay, I'll just go ahead and do it now. So you have V minus 0 over RA, or V minus over RA, okay, plus V minus VO over RB. That should be equal to 0. No? So you have this current plus this current, that is equal to 0 because this current, I minus, is equal to 0. And if I simplify this, what am I going to get? I'm going to get V minus is just V sub O RA over RA plus RB. What does this look like? What equation does this look like? Joseph, do you recognize this equation?
Voltage divider po.
Yeah, that looks like a voltage divider, right? And if you think about it, it is a voltage divider, no? Kasi kung zero ito, kung itong current na to zero, ibig sabihin naka-series lang yung RA at saka RB. No? If this current is equal to 0, these two are in series. And therefore, this voltage V sub O will just divide between RB and RA relative to or proportional to the resistance value. And so this is your voltage divider equation. Okay, so what is now my output, no? V sub O. Well, okay, I'll equate, no? This and this are equal. Itong dalawa equal. Okay, so I equate V sub O RA over RA plus RB is just G1 V1 plus G2 V2 plus G3 V3 all over G1 plus G2 plus G sub 3. No? Or writing this, I'm going to get V sub O is equal to RA plus RB all over RA. Okay, I have G1 V1 plus G2 V2 plus G3 V3 all over G1 plus G2 plus G3. So it is the weighted average. My output is your weighted average multiplied by a gain. Itong gain na to, RA plus RB over RA, that is produced by these two resistances here. The same way that is produced in a non-inverting amplifier. Kasi yung non-inverting amplifier, you just have a voltage applied here, wala itong network na to, and then RB and RA produces a gain. And you get exactly this expression. So ito, parang ito yung effect ng non-inverting amplifier, tapos ito yung effect ng resistor network na to. And I can choose RA, RB, R1, R2, and R3 to get the coefficients I want, no? To get the desired coefficients of V1, V2, and V3. So let me give an example, no? I need additional space. Gawa tayo ng example. Okay. Example. What if I want VO to be equal to 2 times V1 plus V2 plus V3? Example lang to, no? What if I wanted VO to be equal to 2 times V1 plus V2 plus V3? So I can choose, no? Itong limang values na to para makuha ko yung equation na to, no? So, obviously, I would have to make R1, R2, and R3 equal. No? Kasi kailangan equal yung G1, G2, at saka G3. So that this will all have the same. So this will all have the same coefficient. No? So to implement this, R1 should be equal to R2, which should be equal to R3, which should be equal to R. No? Okay. So I now have V sub O is equal to, okay, RA plus RB over RA. Okay. I'm going to have, yeah, 1 over, okay, 1 over R1 plus 1 over R2 plus 1 over R3. Okay. And then, sorry, 1 over R pala yan, no? 1 over R2, no? Equal to R. So 1 over R plus 1 over R plus 1 over R. Okay. Times, okay. Yeah, times 1 over R V1 plus 1 over R V2 plus 1 over R V3. No? Yun ang lalabas. Okay, so this is 1 over G1 plus G2 plus G3. This is G1 V1, this is G2 V2, and this is G3 V3. So I'm going to get RA plus RB all over RA. Okay, this is now going to be 1 over 3R, or this is going to be R over 3. No? R over 3 multiplied by 1 over R, and then you have V1 plus V2 plus V3. No? So this just cancels. So I have 1/3 V1 plus V2 plus V3. So dapat ang RA plus RB over RA multiplied by 1/3, that should be equal to 2. Ito yung 2 dito. No? That's this 2 over here. So I can just choose any value I want now so that that's equal to 2. Okay? So anong relationship ng RA at saka RB, no? So what is this going to end up being? Yeah, that means RA plus RB is going to be equal to 6RA, right? So RB will be equal to 5RA. So those are the values of resistances that I should choose. No? Unang-una, dapat equal yung R1, R2 at saka R3. Tapos yung RB should be equal to 5 times the value of RA. Any questions? Any questions? Okay. Ang challenge dyan is, okay, you should be able to implement you should be able to implement example, no? Let me give an example. And maybe you can try this at home, no? So implement, for example, V sub O is equal to V1 plus 2V2 plus, let's say, 4V3. No? Implement that. Okay? So you have to play around with RA, RB, R1, R2, R3. Kailangan paglaruan nyo to. No? Itong 5 values na to, so that you come up with this particular equation. Okay, so it's really just a mathematical problem now, and that's something that you should be able to figure out. Subukan na lang nyo sa inyong mga bahay, no? Okay, so let's move forward. Okay, here's another example. Okay, this is a difference amplifier. Again, no? First step, check. Meron bang negative feedback? The answer is yes. Part of the output is fed back into the input, into the inverting input, so there's negative feedback. Okay? And then you implement the golden rules for ideal op amps. V plus is equal to V minus. You use nodal analysis, and then the fourth step is check for saturation. Now, if you're not shown the positive and the negative supply voltage, or if the values of Vmax and Vmin are not given, then the assumption is it will not be saturated. So you can assume it will not be saturated. So mag-check lang kayo for saturation kung binigay yung Vmax at saka Vmin. Okay, so let's do this problem. Okay, at the non-inverting input, okay, we apply KCL. What is our KCL equation? You have V plus minus V1 all over R3. Okay, so that's this current, plus V plus all over R4. That's equal to 0. Okay, you have V plus times 1 over R3 plus 1 over R4 is equal to V1 over R3. No? Or V plus, what is V plus now equal to? You get R3, R4 over R3 plus R4 times V1 over R3. So yung R3 nagka-cancel out. So this is R4 over R3 plus R4 multiplied by V1. And if you notice, that is just, again, voltage divider. That is just, again, voltage divider. Bakit mo pwedeng gamitin yung voltage divider equation? Again, because the current flowing through your non-inverting input is 0. So effectively, these two are in series. Kung 0 yung current na nandito sa terminal na to. That's why we get this equation, which is your voltage divider equation. So by doing KCL, we actually just derive the voltage divider equation. Okay, at the inverting input, okay, I have V minus V2 over R1 plus V minus VO over R2. This will give me 0. Let me solve for V minus. I have V minus 1 over R1 plus 1 over R2 Okay, this is V2 over R1 plus V sub O over R2, no? Or V minus is equal to, okay, yeah, R1 R2 over R1 plus R2 V2 over R1 plus V sub O over R2, no? Which is R2 over R1 plus R2 multiplied by V2. So yun yung first term. Plus R1 over R1 plus R2 multiplied by V sub O. That is KCL at the inverting input. So what do I do now? No? So V plus is equal to V minus. I can equate this to this. So this, and this are equal. So R4, R3 plus R4 V1, okay, R4, R3 plus R4 multiplied by V1 should be equal to R2, R1 plus R2 V2 plus R1 over R1 plus R2 VO. Okay. What is V sub O? V sub O will be equal to R1 plus R2 over R1 multiplied by R4 over R3 plus R4 V1 minus R2 over R1 plus R2 V2. Okay. So the output voltage is of the form, no? V sub O is of the form V sub O is equal to A V1 minus B V2. No? Where A is this and B is this one multiplied by this one. Okay. In fact, we can write it out, no? A, sige, V sub O. Okay, A is R1 plus R2 over R1. Then you have R4, R3 plus R4, V1, okay, minus B, okay, R1 and R2, R1 plus R2 cancels out, so you have R2 over R1 V2. Again, no, depending on the coefficients you want, okay, depending on the coefficients you want, you can choose R1, R2, R3, and R4. R1, R2, R3, and R4 to get the desired coefficients. Just like in our summing amplifier, no, you can choose RA, RB, R1, R2, R3 to get the desired coefficients. Okay, let's take up a special case. And that is when R2 is equal to R4 and R1 is equal to R3. No? R1 is equal to R3 and R2 is equal to R4. So this resistor is equal to this resistor, and this resistor is equal to this resistor. So anong magiging simplification nito? No? If R1 is equal to R3 and R2 is equal to R4, ang ibig sabihin nito, okay, R1 plus R2 will be equal to R3 plus R4. So magka-cancel out ngayon ito, no? This and this will cancel out. And I'm going to get V sub O is down now just simply equal to, okay, R4 over R1 is the same as R2 over R1. So this is just going to be R2 over R1, V1 minus V2. So it's a function of the difference. V sub O is a function of V1 minus V2. It's a function of V1 minus V2. That's why you call it a difference amplifier. Because the output is proportional to V1 minus V2, of course, under these conditions. Under these conditions. Okay. The difference amplifier has many useful applications. Okay. No, this is used. One very common use is in instrumentation. Why is it commonly used in instrumentation? Well, let's say that these inputs are connected through very long wires. No, itong mga inputs na to, these are connected through very long wires to a, sabihin natin, a sensor. Okay? Now, ang nangyayari, because the wires are very long, there's going to be a lot of noise that will be coupled to the wire. No? Nagkakaroon ng interference. No? Noise will end up finding itself inside the wire. But the characteristic of noise is it will end up being almost equal in both wires. So by doing a subtraction, okay, the noise in this point at this point and the noise at this point will be almost the same because they will be equally induced in both wires. By doing a subtraction, we end up eliminating the noise. And that's why it's very popularly used in instrumentation. Kasi pag nag-subtract ka, you only get the difference of the two signals. If there's common, you call it common mode noise, that common mode noise disappears. Okay, any question with regard to that? Okay, so let's take up another example. This is a common application of your summer, no? And this is a 3-bit digital to analog converter. Are you familiar with the difference between analog and digital? Can I see a raise of hands? Alam ba niyo yung kaibahan ng analog at saka digital? Are you still with me, guys? Can I ask, no, Clyde, ano yung kaibahan ng analog at saka digital?
I don't exactly remember po, pero to my recollection, ang digital po is a set amount of values po, while analog po has like a graph.
Actually what you described was the difference between discrete and analog, no? Discrete and analog. When you say discrete, there are only specific values that you deal with, no? Whereas analog, you deal with entire range of values. Well, anyway, that related naman yun, ano? Discrete, digital is also discrete, ano? So ang difference is in digital, everything is represented by ones and zeros. In analog, you can have a whole range of values, no? So when you have a variable, when you have a digital variable, that variable can only take on two values. A value representing a 1 and a value representing a 0. Whereas when you have an analog variable, that variable can take on a whole range of values. So if I say my analog variable is from 0 to 5 volts, it can be 1, 2, 3, 4. It can be 1.5, 1.001, 1.0003. No, it can take on an infinite number of values. So this is an example of a digital to analog converter. No, the input to my essentially this is an inverting summer. No? Inverting summer. The input to my summer, okay, are signals that represent either 1 or 0. Now, a 1 is represented by 5 volts in this particular example, and a 0 is represented by 0 volts. For example, if I wanted to represent 100, and this is base 2, I think you're all familiar with base 2. No? You take that up grade school pa lang, you already take up bases. Ano? If you want to represent 100 in base 2, okay, that corresponds to having 5 volts here, 0 volts here, and 0 volts here. So yun yung 100 natin. Okay, and what we want is a circuit whose input is base 2. Essentially, ang input dito is base 2, and whose output is the voltage that that input represents. Okay. So the problem here is to fill the table above with the corresponding analog voltage for each 3-bit combination. So gusto kong buuin itong table na to. Okay, do you understand the problem? Can I get a reaction? Naintindihan niyo yung problem? Okay, good. Okay, so gawin natin, ano? So let's consider the combination 0, 0, 0. Okay. Consider 0, 0, 0. So ito yung combination na to. So anong ibig sabihin nun? My circuit will look like this. Okay. R2, R4, R. This is R. This is 2R. This is 4R. And this is V sub O. And this is also R. Anong value ng V sub O? Anyone? What is the value of V sub O? Can somebody tell me what V sub O will be?
Sir, is it 0?
Yeah, V sub O will just be equal to 0, no? Dahil ang voltage mo dito will be equal to 0. The voltage here will be equal to 0. Why? No? If I apply KCL here, well, first of all, sorry, no? Yeah, the voltage here will really actually be equal to 0, no? My point is the current here will be equal to 0. No? Current here will be equal to 0. If I apply KCL here, okay, what is that going to be? That's going to be V minus 0 over 4R plus V minus 0 over 2R plus V minus 0 over R plus V minus V sub O over R is equal to 0. Okay, but this is all 0. All your V minuses is equal to 0. Right? So you're going to get V sub O over R is equal to 0, or V sub O is equal to 0. But actually, it's obvious. Pag tinignan mo to, no? The output will be equal to 0. So dito, ang output natin is 0 volts. Okay, let's consider this. Let's consider this combination. No? So let's consider (0, 0, 1). So ano yung 0, 0, 1? My V sub O is equal to 5 volts. No? So this is going to be R. This is going to be 2R. And then here I will have 5 volts for R. And this is going to be R, and this is going to be V sub O. Okay. Yeah, my voltage here will be 0, no? But anyway, let me apply KCL here. No? What is my KCL there? I'm going to get V minus 5. Meron akong 5 volts dito, no? V minus 5 over 4R. Okay. Plus V minus 0 over 2R. Plus V minus 0 over R. Okay. Plus V minus V sub O over R is equal to 0. Now this is all 0. V minus is equal to 0. These terms here are also 0. Okay. So I'm going to get V sub O over R is equal to 5 over 4R. Or V sub O is equal to 5/4 volts or 1.25 volts. 1.25 volts. So dito, this is 1.25 volts. Okay, now let me try this combination. 0, 1, 0. So consider 0, 1, 0. So, hindi ko na i-redraw, no? 0, 1, 0, ibig sabihin ito ngayon yung 5 volts ko. Right? So this will be 0, this will be 0. So if I simplify my equation, I'm going to get V minus 5 divided by 2R. Okay. Divided by 2R plus V minus V sub O all over R will be equal to 0, which will give me V sub O over R, okay, is equal to minus 5 volts divided by 2R. No? Because again, remember, V minus is equal to 0 because your plus terminal is grounded. No? By the way, this is negative. No? Sorry. Kalimutan ko yung negative. It's negative. Okay, so this is minus 2.5 volts. No? Shouldn't write it this way. V sub O is equal to minus 2.5 volts. So this is minus 2.5 volts. Okay, what when we have these two now, both 1? What principle can I use? What principle can I use when both of those are 1? That you just studied last module. Anyone? Can I ask Team C? Do you know what principle can you use?
Sir,
Make a guess.
when yung resistors po and parallel are equal.
No. It's a network theorem, no? So I know the output voltage when I have this acting alone, no? And I know the output voltage when I have this acting alone. So now I have these two acting together. What principle can I use? Do you? Wala pa
Sir,
rin?
yung superposition po.
Exactly. You can use the principle of superposition, no? So, in effect, minus 1.25 is the output voltage when this is acting alone. Minus 2.5 is the output voltage when this is acting alone. When these two are acting together, I can just add these two. No? So this is going to give me minus 3.75 volts. Okay. So actually, for me to fill up the table, if I can get the output voltage with V2 acting alone, then I can fill up the table already. No? So so what I want to consider is 1, 0, 0. No? So consider 1, 0, 0. So 1 is V2. So dito nakakabit yung 5 volts, and then that's 0 and 0. Okay, so it's V minus 5 over R plus V minus V sub O over R is equal to 0. No? So the R cancels out, and your V sub O is equal to minus 5 volts. No? So this is going to be 5 volts. Sorry, it pala, minus 5.00 volts. Sorry. Dito. Okay, so what will be the value of this? Albert, ano magiging value nito? You have this and this acting together.
Bali po, ano po, negative 6.25 volts.
Yeah, this is going to be minus 6.25 volts. Okay, and then dito, dadagdagan mo uli ng 1.25, this is going to be minus 7.5 volts. And finally, this is going to be minus 7.5 plus 1.25, no? 8.75 volts. Okay, so notice that your output is proportional to the binary or to the base 2 number. Your output is proportional to the base 2 number. No? As a matter of fact, there's a formula for your output. Ano? V out is equal to, in this particular case, no, V out is equal to 10 times, let me call it B, no? 10 times N na lang. 10 times N, I don't want to use N, sorry. 10 times X, 10 times X over 2 to the N. Where X is the decimal equivalent of the base 2 number, and then N is the number of bits, no? Number of bits. For example, dito, what is 110 in decimal? What is 110 in decimal? Anyone? Yung 110 base 2, ano yun sa decimal? I guess people are kind of asleep, ano? So anyway, sige, example, no? Yung 110 in base 2 is equal to 6 in decimal, no? And then N is equal to 3, no? That's 3 bits. So you have your V out is equal to 10 times 6 over 8, no? So this is going to minus negative, no? So this is minus 7.5, no? Volts, which is what you see here. Okay, so that's an example of an analog to a digital to analog converter. Okay, this is an exercise. Try it out on your own. Instead of resistances, what I showed here are Z. Z stands for impedance. You're going to study what impedance means later on, no? Essentially, resistance is to DC as impedance is to AC. But the op-amp will have the same relationship, whether it be impedance or resistance. So you can compute for the relationship between V out and V in, given this particular topology. No? You call this the Sallen-Key filter topology. This is used to implement different types of filters. Okay. So the problem is just asking you to compute for this relationship. Okay, the last thing that I want to discuss with you now is cascading operational amplifier circuits. So far we've talked about single operational amplifiers, single operational amplifier circuits. All of the circuits that I've discussed so far, you only have one op amp. This case, you have one op amp. No, ito you have one op amp, and so forth. Ano? Ito isang op amp lang. No? What happens when you have many op amps and when outputs of one op amp are the output of one op amp circuit is connected to the input of the next op amp circuit? Actually, you should be able to cascade the transfer function or the gain expression. But what you have to do is you have to be careful to consider the loading effect the input of an op-amp stage might have to the output that it is connected to. In other words, when I connect two op-amps together, no, so let's say this is producing my output, I'm connecting this input, I must make sure of what the effect of this input is going to have on this output. So let me illustrate that by means of an example. So here, I have two op amps. They are cascaded together. This is an inverting amplifier, and this is also an inverting amplifier. So the question that you have to ask is this: when I connect this to this, will the output of my first amplifier be affected? So parang ganito, no? Hihiwalay ko yung dalawa. Kung ito, kinabit ko rito, in other words, if I connect these two together, magbabago ba yung output nito? And to determine that, I have to know what this output will see. No? So ano makikita nitong output na to pag kinabit mo to? No? And that is the input. What it will see is the input resistance. No? And we discussed input resistance already previously. No? If you have an inverting amplifier, what does the input look like to what it is connected to? Because this is a virtual short, this Rs of I, the input, is just going to look like R1. Because this is virtually shorted to this. No? In other words, if I put a test voltage here, no? You recall how do you get equivalent resistance? No? One way is to put a test voltage and then you determine what current will flow. If I put a test voltage here, let's say 1 volt, what current will flow through that 1 volt source? It will be 1 volt over R1. No? And therefore, the input resistance is the test voltage divided by the current that it draws, and you're just going to get R1. On the other hand, if I have a non-inverting amplifier, what will my input look like to what it is connected to? No? This input is just going to be an infinite resistance. In other words, whatever this is connected to will not feel a thing because this looks like an open circuit. So, pag pinagkabit ko tong dalawang to, anong mararamdaman nito? No? What this will feel is just a resistor, Rx, that is connected to ground. No? This is what the second stage will look like. No? What the second stage will look like to the first stage. And fortunately, this is not going to affect the voltage here. No? Let me call this V1. So Rx will have no effect on V1, okay, if the op amps are ideal. No? If ideal op amp. Kung ideal tong op amp na to, we can connect a resistor here in parallel with the output, and it's not going to affect the value of V1. So what is V1? V1 is just going to be 5 over 10, negative 5 over 10 multiplied by 2 volts. No, because this is just an inverting amplifier. So this is your feedback resistor, this is your input resistance, this is your source resistance. So 5 over 10 multiplied by 2 volts negative, that is V1. So V1 will just be minus 10 over 10 or minus 1 volt. Yung V1 na yan, dito ngayon i-apply, no? Dito sa input ng stage 2. And what is this? This is again an inverting amplifier. And your gain is 2K divided by Rs of X. In this case, Rs of X is equal to 1K. No? So V out is equal to minus 2K over 1K multiplied by V1. So this is just going to be minus 2 V1, but V1 is minus 1 volt, so V out in this case is just going to be equal to 2 volts. Any questions? Any questions? Okay, if I don't hear an answer, I'll assume there's none. No? Okay, it would have been different. No? It would have been different if, for example, I had a circuit like this. No? So let's say this is my 2 volts. Ano ba yung mga value dito? 10 and 5. Ano? So this is 10. This is 5. Okay, what if, let's say I had 2 resistors here, no? And now this is my output. Okay, this is my output. What is the value of V1 going to be? No, let me call this V2. V2 is equal to minus 5. This is ohms. No? Minus 5 over 10 times 2 volts. Okay. V2 is minus 5 over 10 times 2 volts because this is an inverting amplifier. And then let's say this is R and this is R. V1 by voltage divider, okay, by voltage divider will be equal to 1/2 V2. But the minute I connect, let's say this is Rx, and then this is 2K. The minute I connect these two together, this is no longer going to be the case. Right? Because as soon as I connect these two together, magkakaroon ako dito ng Rx in parallel with R. And therefore, my voltage divider equation will be different. And that's what we call loading effect. So that's what you have to be careful about. No? When you cascade op amps together, just try to understand what the effect of the input to the next stage is going to have on the output of the first stage. Any question? Any question with regard to this? Okay. Okay, here's another example. No? Here's another example. So here I have 3 amplifiers. And these are all, you have two amplifiers here cascaded to this amplifier here. And this is what you call an instrumentation amplifier. Now, this is a true instrumentation amplifier. Okay. The advantage of this instrumentation amplifier is the inputs V1 and V2 have very, very high input resistances, no? Because the current here will be equal to 0. So whatever these are connected to will not feel a single thing. Wala silang mararamdaman because these inputs will not draw any current. So from the point of view of what it is connected to, it's not connected to anything. And that's the nice thing about this instrumentation amplifier. Okay. I'm going to leave this as an exercise for you to do, no? But yeah, the point is to determine the output voltage with respect to V1, V2, and the circuit resistances. And like I said, okay, first you check that there is the requisite negative feedback, which happens in all of the op amps. Negative feedback here, negative feedback there, negative feedback here. Okay, and then you apply the rules, the golden rules for ideal op amps. So what are those golden rules? One is that the currents are equal to 0 into the inputs, and then the other is that V plus is equal to V minus. No, so if V plus is equal to V minus, V2 will be equal to V sub A. No, so V2 will be equal to V sub A, and VB and V1 will be equal to V sub B. No? Yung voltage dito, the voltage here will be equal to the voltage here, and therefore kung ito V2, itong V sub A will also be V2. Kung ito V1, V sub B will also be V1, no? And then the other is V sub E will be equal to V sub F. Okay. And then I can apply KCL here and KCL here. No? So KCL at A. Okay, what will that look like? So I'm going to get VA minus VB over 2R3, but VA is V2 and VB is V1. No? So this is V2 minus V1 over 2R3 plus VA minus VC, V2 minus VC. No? V2, because VA is equal to V2, minus VC over R4, that should be equal to 0. And then I can do KCL at B. No? If I do KCL at B, what is that? VB minus VA, but that is V1 minus V2, V1 minus V2 over 2R3, okay, plus V1 minus VD, okay, over R4 is equal to 0. And then if you look at this is actually the diff amp that we earlier derived an expression for. No? So actually, hindi mo na pala kailangan i-impose tong condition na to kasi alam na natin yung, well, you can, if you want to impose this condition, you're going to end up deriving the equation for the difference amplifier earlier. No? But I can use that result. No? In other words, this whole thing, I can use the result, let's see. Yeah, that's VD, VO is equal to R2 over R1 multiplied by VD minus VC. No? So this is your difference amplifier. So you can combine all of those equations and you should be able to get a relationship between your output and V1 and V2. No? If you want to derive this, you can go ahead and apply Kcl here and Kcl here. No? Sorry. And Kcl here. Okay. Okay, so this is my last example for this afternoon. So again, this has to do with cascaded stages. Implement the following operations using op-amp circuits. Okay, so for this, okay, so itong A, so A, let me just write it. V of O equal to do V1 plus V2. This can be implemented using a single non-inverting summer circuit. No? Non-inverting summing amplifier circuit. So that's the first example we took today. No? Saan nga ba yun? This one. No? I can implement that letter A using this non-inverting summer amplifier. No? All I have to do, first of all, I'll just have two resistors. Then all I have to do is play with four resistance values to be able to get the result I want. No? So that can be implemented using a single non-inverting summing amplifier circuit. So that can be an exercise. No? Let this be an exercise. Okay, but you can also do it by brute force. Let's say ayaw mo mag-compute ng R1, R2, R3, R4. How do we do this by brute force? No? I'll give you an example. Okay. Let's say I have V1. I want to implement first negative 2 V1. Ano? So if this is V1, I can have an inverting amplifier. Okay, let's say this is 20K. This is 10K. So what will this voltage be? This will be minus 2 V1. Because 20 over 10, sorry about this. Wala pala ako sa presentation mode. No? Yeah. 20 over 10 is equal to 2. So at this point, this is minus 2 V1. No? Okay. And then V2, I can pass this to an inverting amplifier with a gain of minus 1. So what is this point going to be? This is going to be minus V2. And then this 2, I can just add in an inverting summer. So I can make this 10K. I can make this 10K. Okay. And 10K. Okay. So what is this going to be? This is going to be V of O is equal to 2V1 plus V2. Okay. Any question with regard to that? So yan, brute force yan, ano? Kung gusto mong a nicer, elegant solution, you can implement this using one op amp. If you want to use brute force, you can just use this particular scheme. And using this scheme, it's very easy also to implement this, ano? Okay. So I'll just leave letter B to you, how to implement letter B. It's my last example. Any questions? Any questions? Yeah. So yung coverage ng exam nyo on Monday, reminder, will be up to op amps. Your quizzes and your problem set will be due, if I'm not mistaken, this Saturday. I think it's going to be this Saturday. And immediately after they are due, I think the solution to the problem set will be published so that you can also review it. And then good luck in your quiz, on your exam on Monday. So that's all I have for this afternoon. Okay. So I'll close the session and when the last person leaves. Okay. Thank you.
Thank you po.
Thank you
Thank you
po,
po,
sir.
sir.
Oh,
Thank you po.